Welcome guys to my presentation, what civil engineering taught me about being a good software developer. This presentation is going to be in two parts. The first part will be about lessons I learned from engineering that made me a good developer, as the title says. And the second part will be about how all the lessons and more have convinced me that computer science is a liberal art. 2 years ago, this is how I used to introduce myself as a candidate professional engineering technologist with the Engineering Council of South Africa, an associate member of the South African Institute of Engineers, and a member of the Institute of Engineers. I also had a scholarship for a PhD for mechanical and environmental engineering. And then this happened. So now this is how I introduce myself as simply a software developer. And sometimes when it's necessary or useful for me, I also state that I also hold a honors degree in civil and water engineering. A little context first before we get down to everything. I've always loved computers and all things tech. I taught myself to code using VB6 back in the day. For some reason, I studied civil and water engineering in university. And for those who don't know, that is a 5-year degree where I come from. I worked as a water engineer for 4 years. And along the way, I fell in love with GIS, that is Geographic Information Systems. And because of that, I worked as a GIS specialist for 3 years after that. Then I finally gained the courage to make the switch. One question that I usually get when I talk about this experience of mine is why I made the switch and what inspired it and how I was able to draw these parallels. So I have a little illustration that talks to that point. We live in two worlds. That is the natural world and the man-made world. The natural world is self-regulating and the man-made world needs to be managed. These two worlds are continuously at odds, and humanity is continuously trying to come up with new ways of reforming and adjusting the natural world so that it can accommodate and exist as harmoniously as possible with the man-made world. This is my understanding of what civil engineering is about. It's about retrofitting our man-made world into the natural world and ensuring that the natural world fights back as little as possible. Fundamentally, it's about problem solving, continuously finding ways of making these two worlds, which are at odds, coexist. This last statement is why I found it worth drawing parallels between civil engineering and software development. Fundamentally, they are both about problem solving, which I love. And then just a quick summary of the points that I'm going to talk about. There they are. I just want to give this disclaimer that these include things I learned and directly transferred into software development, and things that gave me a perspective with which to view certain aspects of software development. To avoid confusion, in this presentation, when I say engineer, I mean civil engineer. And when I say software developer, I also mean software engineer. I haven't quite learned the difference between the two, and the gatekeepers of the other engineering I come from are pretty clear on who they allow to use the title engineer. So I'm going to stick to that. That's what I know. Also, in each of these, I will first give my observation from engineering, then my observation from software development, then how that made me a better developer. So the first point, always be open to learning. A good civil engineer never stops learning. A lot of engineering is based on foundational science with certain standards in place that help engineers streamline the application of that science. Civil engineers need to continuously think about how to challenge what is existing in order to achieve greater efficiency. Without a firm understanding of the advances, it is difficult to confidently develop solutions that solutions to challenges that emerge on a regular basis. For example, I was once involved in a water demand management study where we had to develop a strategy for reducing water demand and improve conservation in the city that I used to work for. One of the key deliverables was that one of the key discoveries was that the demand management strategy that was in use at the time was based on a study that had been done 2 decades ago. Because it was working, even though it was working inefficiently, no one had ever bothered to update it since it had been put in place. So much research had been done in the field, and there were so many opportunities to reduce demand quite significantly from water loss in the system. But because the people who were in charge and responsible of the system had never bothered to continuously learn and improve, uh, each year the utility was losing huge amounts of revenue. A good developer keeps learning and learns faster. Software development is similar in that there is also foundational science, as well as standards applied to the technologies and frameworks, though without as much rigidity. Software development changes much faster, which means that older ideas and methods also become obsolete faster. Software developers are always aiming at a moving target, and that is part of what makes it exciting. If you slack, your prized skill can become outdated pretty fast. As a result of this, I always seek to learn more and to expand my capabilities, even if I'm tackling the same old problem. I make the effort to read further. I've found that learning something new can widen my perspective and give me a better vantage point, which reveals aspects that I previously couldn't see. Second point, learning is a gradual process. A good civil engineer must demonstrate that they know how to do the job before they start. Civil engineers generally need to figure out to a high level of detail how each project will be completed before beginning. This is important because in most cases there's a lot at stake, including people's lives and considerably high amounts of public funds. Mistakes are significantly difficult and costly to correct. Therefore, stakeholders want to know whether or not the engineers they are working with can design and construct the sewage treatment plant that will live for 50 years before they allow them to use their money. Whilst engineers have a bit of wiggle room, clients want to know, again to a high level of detail, exactly how they intend to do the work. On the other hand, a good developer should get comfortable with learning on the job. Unlike engineering, where clients want to be sure of your practical skill set, if you want to be sure that your practical skill set is solid from the get-go. In development, they usually want to know whether you have what it takes to figure out what it takes. Software development has more wiggle room then, and the plan will probably change along the way. Because I was used to having to prove the plan before the get-go as an engineer, this mindset shift was difficult for me. However, it became clear over time that as a developer, I didn't need to prove a plan. I needed to prove my capability. The plan, after all, would probably mutate along the way, possibly pretty significantly. Now, this influenced me as a software developer in that I'm learning not to get stuck on the research. I have started letting the requirements of a project direct my learning. I break down the work into what I do know and start with that. I research the parts that I don't know as I get to them so that I can keep moving. I remind myself that I don't always need to know how to do every single thing that needs to be done. To this day, the tasks that I encounter on the go are what direct my learning. If I had begged out because I didn't understand, all the corners of what needed to be done, I would probably still be trying to gain the knowledge that would make me feel confident enough to start. Point number 3, it takes time and commitment to get it right. In addition to having the entire final plan, the first cycle in engineering is usually the only cycle. A civil engineer needs to design and construct to the final spec on the first trial. Civil engineering projects often adopt a waterfall approach to project management, where each step in the process is done to completion before moving to the next step. Where redoing something does become necessary, it usually comes at a very high cost. This means that often engineers want to build the final solution the first time around and not to have to come back to it for at least a few decades. Best case scenario, they would only come to it for demolition, which in most cases would have been accounted for in the initial implementation plan anyway. A good developer, on the other hand, embraces the fact that they will learn and improve on the go. In many cases, neither the developer nor the client has a clear picture of what the final product needs to look like. Therefore, development often takes an iterative process to project management, where in each iteration we produce a working solution to the best of our abilities, our knowledge, and our resources at the time. This means that it is entirely acceptable to have a product that is never really done. Over time, I've realized that after reaching the first version of a solution, I have gained so much insight about how the final version should function that I can work much faster. Found that my eyes are opened to potential possibilities and pitfalls as I go, which has proved to be more useful than spending time trying to figure out before building anything. This has influenced me as a software developer in that I've started focusing and having a partially working whole to help prioritize the details that need the most attention. I have accepted that sometimes I need to see how something breaks to understand how to make sure it doesn't break again. This would obviously be a bad idea in engineering. And then point number 4, to stay in the game, you must stay on your toes. A good civil engineer works around the fact that change happens relatively slowly in the field. In civil engineering, innovation for a lot of problem areas doesn't happen very fast. And where it does, it's not adopted very fast. For example, while the technology used to treat wastewater has remained largely the same for over a century, the composition of the wastewater itself has changed quite drastically in that same period. This has caused a lot of problems in the environment, and we now are forced to react, a reaction which is coming many years overdue. The reason for this is that huge infrastructure networks lead to natural monopolies, where it becomes more cost effective to have one player rather than multiple in that particular industry. Unfortunately, this has also meant that one player has no competition and therefore little incentive to innovate. Thus, wastewater utilities have had little to nothing pushing them to innovate. As long as the environment can still take the effluent, there's no reason to make changes. It's therefore possible to perfectly know the ins and outs of a particular knowledge area in civil engineering because of that slow rate of innovation. However, a good software developer works to keep up with rapid innovation. Aggressive competition drives rapid innovation and continuously changing approaches in software development. It's not entirely possible to perfectly know the ins and outs of a particular knowledge area. And this has influenced me as a software developer in that I have adopted a mindset that once we have met our target and shipped the product, it's time to relook at our solution and think about where and how we can innovate. No solution is ever really complete in software development, there's always something that can be improved. I've realized that there is a continuous need to improve performance, to increase efficiency, to provide better user experience, and so forth. In development, as soon as something is complete, it's time to rethink it. Knowing that the technology around me is changing keeps me excited about software development every day. So here are those points again in case you missed or forgot something. Number one, always be open to learning. Number two, learning is a gradual process. Number three, it takes time and commitment to get it right. Number four, to stay in the game, you have to stay on your toes. Okay. Now to the second part of the presentation. Computer science is a liberal art. Having learned from my experience, I spent the past year learning about the experiences of professionals I've met who've moved into tech from other disciplines. This, together with my own experience, has built an interest in me about transferable cross-disciplinary skills and their utility. Most disciplines have elements in the training of their professionals that give them a distinct way of thinking. For example, the way you learn about race in a social science class and the way you learn about it in a biology class and the way you learn about it in a literature class are all very different, but they complement each other in really important ways. As a result, doctors think in a certain way that's distinct from how lawyers think, and so forth. And I believe that these distinct ways of thinking can be incredibly valuable to other disciplines. In problem solving, seeking out perspectives of different of people different from you can help to avoid some cognitive traps that people similar to you probably share with you. The frame of reference that a person uh, comes from informs the way they see the world. So when you have multiple frames of reference, especially when those frames of reference are dissimilar, you end up with a richer array of information. And with better information, you typically are able to make better decisions. This is especially important in tech, and particularly in tech in this age, where it has become so pervasive and tech solutions are being built for all kinds of disciplines. Today, more than ever, it's more valuable to have software developers who do not only understand the disciplines they build for, but also have some real experience in them. What makes a tool great is its ability to effectively solve people's problems. And who better to concretely understand and communicate these various problem domains than professionals who've worked in those fields and interacted directly with the people for whom the solutions are being built. It's out of these experiences that I've come to subscribe to the perspective that computer science is a liberal art. So what is a liberal art? There are many definitions of liberal arts, but here are some of the more interesting ones that best explain my point. The first one is that liberal arts is an intellectual tradition that focuses on developing the critical mind across a variety of disciplines. Liberal arts education is a broad exposure to the outlines of knowledge for its own sake. One way to understand liberal arts is to consider the meaning of the word liberal. Liberal, which is related to liberty, has to do with the idea of freedom, or in this context, having a free mind. So liberal arts education is the kind of learning that frees the mind to think for itself and to continue learning throughout life. Ultimately, the purpose of liberal arts education is to expand our worldview, to make us more expandable and adaptable in terms of our curiosity and awareness of what's going on around us. Whatever job you choose to take, the concrete stuff you learned at college, whatever it is, will become mostly or entirely irrelevant depending on the field that you're in. And given the pace at which industries are changing, there's increasing value in more abstract skills like problem solving and collaboration, how to communicate well and clearly in writing and in speech, how to learn from others and how to teach others in all kinds of environments. Those are the kinds of skills that transcend any specific job. And those are the kinds of skills that computer science is great at teaching. Skills for being flexible thinkers who can solve problems, who can work well with others, and think well and research and analyze. When you don't pay attention, it's easy to think that these skills are fragmented and atomic, but they are quite pervasive and affect how we conduct all parts of our lives. Every public school teaches math and language because they are foundational to other pursuits. In today's world, computer science is also foundational, and teaching it to everyone would incredibly empower them with the skills for self-expression in this age. We don't learn grammar or how to punctuate for its own sake, or so that we all become journalists and writers. Once you know how to read and write, you use those skills to learn new ideas and to create your own ideas and to share them. The same can be said for computer science. Computer science skills are just tools for you to use in your problem solving. That's why computer scientists are now leading researchers in many non-computer science fields, because computer science gives them the tools for problem solving, which can be applied anywhere. A similar perspective exists outside of academics. Schools teach science to everyone so that they get better at understanding the world. We're now in an age where technology is just a niche business tool, where technology is not just a niche business tool anymore, but a means of self-expression. Just like how liberal arts were to give citizens the basic skills they needed to meaningfully contribute to society, computer science is the language by which we gain the means to contribute in this age. It is the current tool of choice for shaping reality. It is the interface by which we connect with the world around us. Therefore, we need a radically more diverse set of people to build these products that connect us with the world to ensure a rounded experience. And that's why we need to make this call for all sorts of professionals to come and join the field of computer science and bring their knowledge. But you may be wondering, because everyone here is already in tech, so why is this relevant to us here right now? The traditional liberal arts had their heralds who were at the helm of shaping society and who in many ways contributed to building the world into what it is now. Computer science as a liberal art also needs heralds, and I believe that people in this place are prime candidates for heralding it and shaping what society is going to look like for coming generations. Computer science and indeed all other liberal arts can help you get a good job and enhance your professional life. That is important, but life is more than just that. You need a good job, but you also need a good life. Computer science knowledge opens numerous ways to enrich and ennoble life. That is, that is good news. And we here are well positioned to spread that good news, because in the coming years, when you take a cab, when you watch a TV show, when you explore a new country or learn a new language, that experience is going to be shaped and deepened by the computer science knowledge that you possess. We here are the ones uniquely positioned to help people see the computer as not just a black box, but as a toolbox that they can open, tinker with, and build great things. Thank you so much for listening. Are there any questions? Question one says, would you say young stars have a better chance in software development since they are most up to date with newer tech? Or should I say they are fresh and still curious to know more? Uh, I would say yes, because they're starting from a clean slate, right? They don't have some of the cognitive biases and some of the they don't need to make some of the paradigm shifts that a lot of older people need to make. So I really think we should support all of the movements that are doing work to ensure that kids are taught to code and that kids are taught computer science knowledge. That is something that can seriously contribute to how the world is going to look tomorrow. And that is something that I think we should all give a deliberate and intentional effort towards. Okay, let me check for more questions on Slack. Somebody say it seems like a generalization to say stars, young stars. I think you meant stars. To say young stars are more up to date. It's of course a generalization, right? And if you look at audiences such as the one similar to the audience that is there at DevConf, there are definitely a lot of much older people who have a much deeper and much wider understanding of computer science and the principles and all of that. So the point I was making with young people is to say young people are uniquely positioned to be able to grasp this stuff because they're coming from a clean slate. Notwithstanding the fact that there's older people who already have this knowledge, but it would be easier to teach computer science knowledge to a young person that who never knew about computer science, as opposed to teaching an older person who already had knowledge in a different field. Are there skills you can identify that software developers can learn from civil engineers, perhaps? I think, well, of course, in addition to a lot of the other stuff I spoke about, I think one thing that engineering is very intentional about, and this stems from the fact that engineers are required to, first of all, have a full understanding of the entire scope of the work from the get-go, and also that the first time they build things is the only time, so that it's perfect the first time. So there's a huge focus in engineering that before a big project, you get into this zone or into this time where you study and revise all of the scientific concepts that will go into whatever you're building. I know this is not something, maybe this is not something that can be directly translated to software development, where we get into a great time of study to prepare for a software engineering project. But I found that helped in engineering to ensure that at any given point, my knowledge of the foundational science is kept tip top, because I'm always studying and I'm always reflecting. And I'm forced to do that. It's not something that I choose to do just out of my own initiative. And then there's a question that says, can you recommend any resources that helped you adapt into the new field? The time we're in right now is a very exciting time, because there's a lot of knowledge out there on the internet that is freely available and that people can learn from. And I'm one of those people who can attribute most of my learning in software development to purely freely available resources on the internet. You go on YouTube, there's a ton of information there that is freely available. And that's just like one platform. I do, however, think that abundance of information can sometimes be a crutch to somebody who's starting out, because especially when you are just starting out, you don't know and you don't have a good filter to determine what information is useful and what information is not useful. So that abundance of information can be overwhelming at times to somebody who is starting out. All right, doesn't look like there's any questions from anymore. Thank you very much for giving me this time. It was my first time presenting at a developer conference, and it was my first time presenting over a live stream. So it's been quite an experience, and I really enjoyed it. And like everyone else has been saying, please keep safe and enjoy the rest of DevConf. There's one more comment. I found that software engineers, if left to their own devices, pay little mind to the problem domain and focus mainly on showcasing their skills. Yeah, 100%. And this is a great lesson, right? It links very well with what I was just talking about, that in engineering, you are forced to go back to the principles, right? And so it's not just about displaying your prowess in how you can design systems, right? A big focus is on ensuring that you build a system that works. And because of that requirement that it has to work the first time, you will really invest yourself into ensuring that you focus on the fundamentals, right? If it's a structure, I need a structure that will stand, that will work, that will be safe, and all of that. And if there are any embellishments and aesthetic elements on top and new technologies that are not tried out, I will only consider that after I've made the initial considerations of the requirements that really matter. Great talk. Thanks. Thank you. Congrats. Thank you. Great talk. Thank you so much. Okay. I'll continue this discussion on Slack for all those who have any more questions. Just ping me on Slack or on Twitter. Otherwise, thank you for attending my session. Enjoy the rest of DevConf.